Hi there. Hope you have a fantastic day today. This lesson, I will teach you continuous probability distributions. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one, to work out whether the function is a continuous probability distributions, so we need to work out the area under the curve for a given domain. Okay, it must equal to 1. So in this case here, the domain is 0 to 3. So we need to work out the area between 0 to 3. If it is equal to 1, it is a continuous probability distributions. So let's work it out, see if it is equal to 1. So area is equal to, from 0 to 3, that is 1 over 9 x squared dx, because it's from 0 to 3. So what I do, easier if I take 1 9 out, okay? So easier. So I take 1 over 9 integrate x squared dx is from 0 to 3, of course. Now to work this out, so remember the rule, integrations of x power n dx, that will give me n plus 1. So that means n plus 1 divided by n plus 1. And we add c, but in this case, it's definite integration, so we don't need to add c. So now what I do, so we have 2, we add 1 to it, will give me 3, 1 over 9, I write this down. So x to the power of 3 divided by 3. And from 0 to 3. Now, to work it out easier, if I take a third out. So if I take a third out, so 1 9 times 1/3, because this is 3 underneath, so we take 1/3 out. So 1/3 times 1 9 is give me 1 over 27. So x to the power 3, 0 to 3. It's just easier, that's all. So now I just replace 3 with x. So that will give me 1 over 27. So 3 power 3. So 3 power 3 minus, so 0 power 3. And we know that 0 power 3 is 0. So just write minus 0. And we have 1 over 27 times 3 power 3 is 27. Otherwise, you can just put that on the calculator exactly the same as it is. And you should get 1. Because this 27 here, simplified, give me 1. So 1 times 1 is 1. And since the area is equal to 1, so therefore it is a continuous probability distributions. Second one, again, we need to work out the area from 1 to 4 to see whether it is equal to 1 or not, okay? So area of this function here is integrate 1 over 8 x minus 1 square dx. And of course, from 1 to 4. So 1 to 4. So now what I do, I just take 1/8 out first, okay? Because it's just a constant. So it's just easier. That's all. You don't have to, but easier if you do that. So 1/8 integrate from x minus 1 power 2 dx is from 1 to 4. Now, don't forget, if we integrate these kind of functions, so integrate ax minus 1 power n dx, so that will give me ax minus 1 power n plus 1, because we integrate, we add 1, and we divide by n plus 1, and we times by the derivative of this. So that is differentiate ax minus 1 will give me a. So we times by a as well. So keep that in mind. So what I do, I just write this 1/8 down first. So that will give me, so if we add 1 to 2, so that give me 3. So let me just write this down. So that is x minus 1 power 3. And we divide this by 3, whatever that number here. So now we differentiate inside the brackets. This one here, we differentiate 1 is 0, of course. We differentiate x is 1. So different, in another word, differentiate x minus 1 is equal to 1. So we times by 1. And it is from 1 to 4. So now I just substitute the value in. So what I do now is I just simplify this a bit further. So these two times together give me 3, and I can just take a third out because it's over 3. So if I take a third out, so a third time 1/8 is 24. So 1 over 24. And let me just rewrite this, become x minus 1 power 3 from 1 to 4. So now I just replace x with 4 minus x with 1, okay? So that is equal to 1 over 24 bracket. So x replace with 4, so that become 4 minus 1 power 3. We minus, and 1 minus 1 is 0, and power 3 is still 0. So just write like this. So there you go. So 4 minus 1 is 3. So that would give me 1 over 24 times 3 power 3 minus 0. And we know that 3 power 3 is 27. So the answer is 27 over 24. So it's equal to 27 over 24. That is 1 and 3 over 24. So we know that the probability cannot be more than 1, right? So therefore, it is not a continuous probability distributions. Okay, keep that in mind. Please pause the video and try this one yourself. Hi there, I'm back. How did you go? So let me just go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So to work out whether it is a continuous probability distributions or not, we need to find the area under the curve from 0 to 3. Now, let's get into it. So area is equal to integrate 1 over 16 x to the power 3 dx is from 0 to 3 within this domain here, okay? Keep that in mind. So what I do, I just take 1 over 16 out. So 1 over 16 integrate 0 to 3 x to the power 3 dx. So to integrate x to the power 3, so 3 plus 1 is 4. So x to the power 4 over 4. So that is equal to 1 over 16. So x power 4, because 1 plus 3 is 4. We divide by 4. And this is from 0 to 3. So what I do now is I just take the 4 out. That is a quarter. So I take a quarter out. So that will give me 1 over 16 times a quarter. So 16 times 4, we double 16 is 32. Double again will give me 64. So that answer is 1 over 64. X to the power 4 from 0 to 3. So now we just evaluate this. So that would give me 1 over 64 and then 3 power 4 minus 0 power 4. And 0 power 4 is 0 anyway, so just minus 0. So there you go. And we know that 3 power 4 is 81. Otherwise, you can just put down a calculator exactly same on the screen and you should get the answer. That is 81 over 64. So 81 over 64. Let's just put down a calculator if you like. So we just have, so 1 over 64 and brackets, and then brackets again, 3, close bracket, power 4, and we minus 0, and brackets. So there you go, 81 over 64, press the SD button, it gives me 1.265 and so on, or I can write mixed numeral, shift SD, 1 and 17 over 64. So equal to 1, 17 over 64. So that is greater than 1. And we know that the probability distribution cannot be more than 1. So therefore, the function is not a continuous probability distributions. And I hope you got it correct. And thank you so much for watching. Bye.